Okay, so last time we already talked about how to solve the first order differential equation. Okay, let's summarize first. First, we talk about how to find the equation. Okay, so we know the difference between the ODE and PDE. Okay, we know order and degree. Okay, of the differential equation. Okay, we know the properties of the linearity. Okay, and second part we learn how to solve the first order equation. Okay. Okay, there are many ways. One is by using equation. Okay. Homogeneous equation. Exact equation. Okay. And also by using the integrating factor. Okay, and also we know how to solve when it is a linear equation, and also the Bernoulli equation. Okay, so this is what we already learned last time. Now for today we will study others. Okay, so what we're going to focus on today is the first thing is the application. Okay, of order. Okay. In this, the application we focus have only two problems. Okay, one is called the heat problem, and the second one we call it the mixture. Okay, the mixture problem. Okay, so maybe we first start with the heat problems. Okay, the heat problems. What is the heat problem is all about? Heat problem is you want to know the heat transfer between object or the environment. Okay. Okay, so the equation that we are focused is in this form. Okay, dx by dt equal to kt minus x. Okay. Okay. X is temperature. Temperature of the object. Okay. Of at time t. Okay. So x, we can rewrite it as x of t. Okay. Another thing is the capital T is the temperature of the surrounding. Okay. Okay, so dx by dt is the rate of change, right? The rate of change of the temperature. Okay, and K is the constant. Okay, the cooling constant. Okay, so maybe we see some example. Okay. Cup temperature is 27 degrees Celsius. Uh, $29 degrees. Okay, so the question asks that how long you have to place the teacup, okay, until the teacup has the temperature 29 degrees Celsius. Okay, so there are this one. Okay, so it's teacup at time 0, right, is 77 degrees Celsius, and this the room temperature is 25. Okay, and another thing is that after 2 minutes the teacup reached 51 degrees Celsius. Okay, so what we know about this thing, right, is big T equal to 25, right, and also X at time 0, right, is 77. X at 2, right, after 2 minutes the temperature dropped to 51 degrees Celsius. Okay, so we put into our formula here dx by dt equal to k t minus x, right? It's you can write x minus t or t minus x. Okay, so it will become dx by dt equal to k t minus x, right? And k we don't know, but t is 25 minus x. Okay, dx by dt. So we get 1 over 25 minus x dx equal to k dt, like that. And then you integrate both sides. Okay, so you get the log of 25 minus x will equal to kt plus c1, right, the constant. Then you get 25 minus x equal to e kt plus c1. Okay. And since x, right, is greater than the temperature of the object is greater than the temperature of the surrounding, right? So this, okay, will, when you take absolute out, you get x minus 25 equal to ekt plus c1. Okay, or you can just write it like this. Okay. C1 ekt plus 25. Okay. At time t equal to 0. Okay. At t equal to 0, we get x0 equal to 77. Right. So when we replace, we get 77 equal to e to the c1 plus 25. Okay, so we get e to the c1 will equal to 52. Okay, so our answer will update to 52 e to the kt plus 25. Okay, then we know at t equal to 2, right? So at time t equal to 2, x2 is equal to 51, right? Okay. Then we get that 51 equal to 52 e to the 2k plus 25. Okay, we get k equal to minus 0.346. Okay, you can try to calculate it yourself. Okay, so now we get the answer, the solution of our ODEs is equal to 52 e to the minus 0.346 t plus 25. Okay, and we want when xt will equal to 29, right? So we replace xt with 29, and now we find what is the t that make it happen. So it's become 52 e to the minus 0.346 t plus 25. Okay, we will get t is equal to 7.41 minutes. Okay, so this will be the answer of the of this problem. Okay, I have to tell you that here. Okay, and you can use either of them. Okay, equal to kx minus t. I'm not sure which one your lecturer teach you, but it's actually the same. Okay. Okay, so this is one problem. Okay, the application that used. I will not going into the detail on solving the ODE much. Okay, because you already learn about it. Okay. On the next one, that you're going to see is the mixing problem. The problem. Okay, the mixture problem. So in this case, you will the situation will be like you have concentrated water and mixed with another salt dissolving water or something like that. Okay, and see what is how many salt and mixture inside the tank, something like that. Okay, so the equation will be in this form, equal to in minus out. Okay, so suppose this one is the container, right? In here have some mixture in it. Okay, and you put some water in and let some water out. Okay, in and out like this. Okay, so xt, okay, is the quantify substance at time t. Okay, so there will be some substance, okay, like salt, okay, or sugar in is the flow rate. Okay, just flow in rate. Of the mixture. Okay. Is the of sorry. of the substance, okay, and out is flow out of the substance, okay. You can find this and this, okay, by flow out rate of multiplied by the concentration of of the mixture, okay. For in is also the same. That means dx by dt is the rate of change of this at time t. Okay. So let's see the example. Of saline with of salt solution. saline. Cube will mix. Okay. So the question want to find the amount of salt in the tank at any time t. Okay, so now what we get is that this thing, okay, at time 0, we know that we have 10 kilogram of salt. Okay, and also have 100 liters of saline. Okay, we know this one. Okay, add water. So this one will going to be the in, right? And then leave the tank, right? Leave the tank at the rate of this. Okay, so from the differential equation, right? We need to know in first. In is equal to, so they add 12 liter per minute, right? So it's 12 liter per minute. Okay, into the tank. And but this one is a pure water, so there's no salt in it, right? So the concentrated of the salt is 0. So the in rate is 0. Okay. Next is the out rate. Okay, the out rate. Out is 10 liter per minute, right? But what is the amount of salt, right? The concentrate of salt in the mixture, right? It is the amount of salt at time t, okay? Divided by the volume of the water, okay, the saline solution. Okay, the volume of at time t. Okay, so it's equal to 10x, right, over the volume of the mixture is 100, right? Because this one is at t equal to 0, right? And they pour in 12 liter per minute, but the water leaves the tank 10 liters per minute. So the amount of water inside going to be increased by 2 every t, okay, every minute. So it's become 10x over 100 plus 2t. Okay. So now we can solve this differential equation. 10x over 100 plus 2t. Right. This thing will equal minus 10x over 10x dx equal to, okay, and then we integrate. Okay, we get log of 10x over 10 equal to log of 100 plus 2t over 2, and then plus constant. Okay, so you can answer it like this, or you can do something more, right? Just modify it a little bit, so it's become 5 plus 2t plus c, right? And as 10x, no, sorry, there's also a minus here, right? Equal to e to the minus 5 log of 2t plus c equal, this always be positive, right? So we can just take absolute value out, and 10x is also positive. Okay, so we get e to the c, e to the log of 2t, right, minus 5 like this, or we can just write it as a big C, and this thing will be 100 plus 2t of minus 5, like, and x equal to, okay, something like this. And you, if they give you some initial condition, then you can find at a specific time. Okay, so this is two application that you learn in this course, right? The application for first order differential equation, the heat problems, and also the mixture problems. The next thing. Okay, so the next thing that you're going to learn is about higher order differential equation. Uh, Maybe I will start higher order at 5. Okay, 5 o'clock. Let me check first that which technique that you have learned. Okay, so next we're going to find the solution of higher order ordinary differential equation. Okay. Find. Okay. In this, we will focus on a specific type of higher order ODE, right? Called the homogeneous linear equation with constant coefficient. Okay, what does this mean? Right, the ODE is that in this form is a n y n plus a n minus 1 n minus 1 plus until a1 y prime plus a0 y equal to 0. Okay, this constant, right? This coefficient needs to be constant. Okay, it has to be the some number, and here we call it homogeneous. Okay, when it's equal to 0. Okay, so how are we going to solve something like this? We're using what we call the auxiliary equation. Okay, okay, using the auxiliary equation. What does it mean? You replace y y to n with r to the n. Okay, replace y n with r to the power of n. Okay, so n derivative of y, you replace it with r power of n. Okay, so for example, you have this equation, y double prime minus 4y prime plus 5y equal to 0. Okay, so you replace y double prime by r squared minus 4r plus 5 equal to 0. Okay, like this. you can see that I replace y double prime with r squared. Okay. Y prime with r and y with 1. Okay. Like this. Okay. And when you do the auxiliary equation, you find the root of the auxiliary equation. Okay. Next. Equation. Okay. Like this one, if you find the root, you will get r equal to 4 plus 2. 2 plus I and 2 minus I. Okay. And that will help you to find the answer of this ODE. Okay. So the root, right? In first case, when R is real number, okay, and different, okay, R is real and different, so you get y equal to C1, the constant, okay, e to the R1x plus C2 e to the R2x until Cn e to the Rnx. Okay, so R1, R2 until Rn is the root, okay, and that's real number and also different from each other, so you get like this. In the second case, R is also real, okay, but the same. Okay, if it is like R is equal to 1 and another also 1, right? So you will get y equal to C1 e to the Rx plus C2 x e to the Rx plus C3 x squared e to the Rx and so on. Okay, so it depends on how many same R. Okay, if it have only 2, then you will have only this 2. If it have 3, you have to include another one. Okay, if it's 4, then you just keep repeating this process. The third case is R is complex, okay, and different. Okay, then R is in this form A plus and minus bi. Okay, y will equal to e to the ax, okay, c1 cos bx plus c2 sin bx, okay, like this. If in the last case R is complex again and same, okay, the root is the same, okay, R is equal to a plus or minus bi, y will equal to e to ax, c1 cos bx plus c2 x cos bx, okay, plus c3 sin bx plus c4 x sin bx, like this. Okay, and in this case have only two root are the same. If it is three root, then it's going to more than this. You're going to have x squared also. Okay, so from this four type, you can answer this one, right? So this one is is complex, okay, but the different, so we get y equal to e to the 2x c1 cos x plus c2 sin x, okay, so this is the general solution. Okay, okay, so maybe you more example. So it's this y by dx dt squared minus 5 dy by dt plus 6y equal to 0, like this. Okay, if it like this, then you using the auxiliary equation get r squared minus 5r plus 6 equal to 0, right? Finding the root of it, you get equal to 0, right? So you get r equal to 2 and 3. Okay, so you get that the y equal to, it is real and also different, right? So it becomes c1 e to the 2x 2t, sorry, plus c2 e to the 3t. Okay, and then you get the equation, the solution of this higher order. Okay, sometimes you're going to see the operator return this. Okay, so don't have to be panicked. It's the same. You can write this thing as d square minus 5d, okay, plus 6y equal to 0, like this also, okay. D here is for dy by dt, okay, or dy by dx, okay. It depends on what is the independent variables, okay. So what is good about writing it like this, right? Sometimes it's very difficult to find, right? Like this example, d square minus 49, d square, d plus d 0, like this, okay. And if you written it like this, you know that this one, okay, this is not minus, okay. Oh, I just write, okay. You know this one is in the form of auxiliary equation already, okay. So you can find for this d square minus 49, right? We get r equal to 7 and minus 7, okay. I recommend you to do it in a proper way, okay. You just write auxiliary equation first and then finding the root, but and this one, right, I get m no r equal to half and minus a half, right? No, it's a half and a half. And the last one is r equal to 3 plus 11i. Okay, so when you get like this, you know y is equal to c1 e to the 7x, okay, plus c2 e to the minus 7x, plus c3 e to the 1/2 x, plus c4 x e to the 1/2 x, plus e3x, c5 cos square root 11x, plus c6 sine square root 11x, okay, like this. You can see that this and this, right, you can just add them together, okay, like this. The root of auxiliary equation become the, you can change it to be the answer of the higher order. Okay, so hope you can find when it is the in this form, okay, the homogeneous linear equation, okay, with constant coefficient, okay. The next thing that we're going to focus is change it to non-homogeneous, okay. to non-homogeneous linear equation with constant coefficient. Okay, so in this, when you want to solve the non-homogeneous, okay, so let me take this one. Okay, the homogeneous part is here. Okay, on the left hand side is the same. We change homogeneous to non-homogeneous. So this thing is not going to be 0. It can be some function. Okay, g of x. Okay, it can be the g of x. So this become non-homogeneous already. Okay, and when it is a non-homogeneous equation, they have several techniques. Okay, one is by using UC set. Okay, method of undetermined. Okay, the second way is we call it the method of variation of parameter, and the third one we call the operator method. Okay, have 3 ways. How are we going to solve the non-homogeneous linear equation? Okay, how to solve? First, first I have to tell you that the answer, the solution, is in this form. Okay, y equal to yc plus yp. Okay, so this one yc we call it the general solution, and this one is particular solution. Okay, we have to find 2 solutions, the general solution and particular solution. Okay, so how to solve? Okay, first solve for yc. Okay, how are we going to solve for yc? Okay, the general solution, we assume gx equal to 0. Okay, so when we assume that gx is 0, okay, the ODEs, our ODEs will become homogeneous linear equation, right? So we can solve homogeneous linear equation, okay, with constant coefficient, and then you get the answer that's called YC. Okay, for second one, solve for YP. YP, in this case, we have three ways to do: method of undetermined coefficient, method of variation of parameters, and also the operator method. Okay, so using method UC, method of variation of parameter or operator method. Okay, so let's study one by one. Okay. Okay. For using the method of undetermined coefficient, you need to know what is the undetermined coefficient function first, the UC function. Okay. Okay. This is very important for this method. Okay. The UC function has to be in this form only. Okay. 1 is x to the n. Okay. N is the integer, okay, the natural number, and also 0. Okay. So 0, 1, 2, 3, 4, 5, and so on. 2 is e to the ax, okay, where a is the constant, can be real number, okay, but need to be the constant. 3 is cos of bx plus c, where b and c are constant, but b is not equal to 0. And 4, sine of bx plus c also. And the condition is the same. B and c are constant, and b cannot be 0. Okay, this 4 form, or another one is the fifth one is the 1 to 4. Okay, so what is mean the finite product? You can have like x to the n, like e to x. Okay, this is also the UC function. Okay, or e to the x cos to x plus 1. Something like this is also the UC function. Okay, the finite product. Okay. And if you already have this know the UC function, you can use the method of undetermined coefficient if the gx is UC function. Okay, I have to say the one. Okay, product or addition. Okay, so the sum product or sum. Okay, you can have x and it can be like this, but okay, that's just the product. Okay, you can use method of undetermined if gx is the sum of UC function. Okay, gx is the sum of UC function. Only if not, you cannot use the method of undetermined coefficient. Okay, so maybe you will see from the example. Okay, how to solve. Suppose d square 4d minus 5 y equal 3 sine 2x plus 5x plus 4. Okay, first find yc. Okay, you can try to find it yourself. Okay, but yc will equal to c1 e to the minus 5x plus c2 e to the x. Okay, so this is yc. You find the solution of d square plus 4d minus 5 y equal to 0. Okay, you will get this thing. Okay, now find yp. Okay, we get gx equal to 3 sine of 2x plus 5x plus 4. Okay, this is gx and is the sum of UC function, right? Okay, so we make the UC set of 3 sine of 2x is sine 2x and cos 2x. Okay, of 5x is s2 x and 1 of 4 is just 1. So the UC set, right? UC set is S equal to S1 union S2 union S3. Okay, so this will become sine 2x cos 2x x and 1. Okay, when you get UC set already, yp is in the form of UC set, so it's become a sine 2x plus b cos 2x plus c x plus d. Okay, you get this one. Now what you're going to do is that you're going to from the question, right, differential equation here, you can see you have d squared and 4d, right? So you differentiate. Okay, so dyp will equal to 2a sine 2x, no, sorry, 2a cos 2x plus 2b minus sine 2x plus c, like this. Okay, and d square yp will equal to minus 4a sine 2x minus 4b cos 2x. Okay, just this one. So d square plus 4d minus 5 y will equal to minus 9a minus 8b sine of 2x plus 8a minus 9b cos 2x, and also minus 5 sine minus 5cx plus 4c minus 5d, sorry. Okay, and this thing is also equal to 3 sine of 2x plus 5x plus 4, right? So you can see that here's sine x, this is sine x, right? So that means this have to equal to this. Okay, 5 it have to equal to this. Okay, and 4 have to equal to this one. Okay, and you can write it as 0 cos 2x, right? So 0 have to equal to this one. Okay, so we get minus 9a minus 8b equal to 3. 8a minus 9b equal to 0. Minus 5c equal to 5. And 4c minus 5d equal to 4. Okay. From this, you get a equal to minus 27 over 145. B equal to minus 24 over 145. C is equal to minus 1. And D is equal to minus 8 over 5. Okay. Now you already get YP, right? YP is equal to A sine 2x, right? So it's become minus 27 over 145 sine 2x minus 24 over 145 cos 2x minus x minus 8 over 5, like this. Okay, so now you get the solution already. The solution y equal to yc plus yp. So this thing will equal to c1 e to the minus 5x plus c2 e to the x minus 27 over 145 sine of 2x minus 24 over 145 cos 2x minus x minus 8 over 5. Like this. Okay. So from this thing, I think you can have some ideas on how to solve by using the UC set. Okay. So what is important is that gx has to be the sum of UC function. Okay. For you to use this method. Okay. If it's not, then you cannot use this method. Okay. Okay. Sorry. Wait. Okay, so the next one is the variation method. Okay, for the variation method, I think you will see only the second order. Yeah. Okay. The next one is called the of yeah, of parameter. Okay, so for this one, I will focus on the second order. Okay. So it's become A2 plus A1 okay. Okay, so it's in this form, right? First step of this thing, okay, is that you divide A2 to all of them, okay? A to x, okay? Dividing A2. So the ODEs will become A1 over A2, 1 prime, A0 over A2, 1, GX over A2, like this, right? You can change it to P of x, y plus Q of x, like this. Okay, so the method of variation of parameters is have one benefit, okay, which is that you can use when it not a constant coefficient, okay. It can be the function, but it needs to be linear, okay. So it's non-homogeneous linear equation, don't have to be constant coefficient, okay. So I can write it as px, qx, and gx, okay. It can be function of x, okay. So when you get this one already, right, you doing the same, find yc first, okay, and yc is the homogeneous equation, okay. You can try to review about it, okay. Okay, so first find yc, okay. Homo okay, homogeneous equation, okay. But I think in the exam you most of the time you're going to see the px, qx, and px and qx be the constant, okay. So you can using the method that I teach before here, okay. When it's the third one is finding yp, okay. This is the hard part, okay. So you get yc equal to c1 y1 plus c2 y2. Okay, y1 and y2 is the solution of it. Okay, then now you're finding yp, right? Yp is in the same form. Is you change it to v1x y1 plus v2x y2. Okay, like this. Now you differentiate this one. So y prime p, yp prime going to be v1 y1 prime plus v2 y2 prime plus v1 prime y1 plus v2 prime y2, like this, and differentiate another one. Okay, okay. Now we want to avoid the derivative of the second derivative of unknown variable. Okay, so which is this one. Okay, because when we doing the derivative, this thing, what going to happen is that you're going to have the second derivative here. Okay, so we will let this thing equal to 0. Okay, so you can just delete it. Okay, and yp here you just going to use just this one, y1 plus v1 prime y1 prime like this. Okay, and now we get this thing. You just plug this into your first ODE. Okay, and then you try to find the answer of it. Okay, maybe you're going to see it more clearly when it is the example. Okay, so the example, d square plus 1 y equal to. Okay, as you can see here, you cannot use UC set, right? The method of undetermined coefficient. Okay, so in this, I'm going to use the method of variation of parameters. Okay, so since this one is constant coefficient, right? So I can find yc, which is yc will equal to c1 cos x plus c2 sin x. Okay, you can try to find it yourself. Okay, the second one, I want to find yp, right? So become v1 cos x plus v2 sin x, like this. And when you plug everything, right, finding this all, okay, you will get the two equation. One is that, okay, 1 plus v2 prime y2 equal to 0. This is one system of equation. Another is v1 prime y1 prime plus v2 prime y2 prime equal to g of x. Okay. So in this case, g of x is sec x tan x. Okay. So if I want to find v1 prime, I can use a matrix to find sin x, tan x, and cos x over okay, and that equal to minus tan square x. Okay, and v2 prime is equal to cos x 0 sin minus sin x x tan x over sin x. Okay, and this becomes tan x. Okay, maybe I just v1 prime will equal to 0 y2x g of x y2 prime x over y1x y2x y1 prime x and y2 prime x. Okay, and v2 equal to y1 x 0 y1 prime x and gx over y1x y2x y1 prime x and y2 prime x. Okay, and after this you can find v1 and v2, right? v1 is equal to minus integral of tan square x dx. Okay, right, and this thing is x tan x. v2 equal to integral of tan x dx, right? It's log of sec x. Okay, so we get yp equal to x minus tan x of cos x plus log of sec x and sin x. Okay, so y equal to yc plus yp, that equal to c1 cos x plus c2 sin x plus x minus tan x cos x plus log of sec x sin x. Okay, so this is the solution of the ODE. Okay, So I hope you're going to review, and I left with some of the topic. One is the operator method, right? The second one is the application of higher order, okay, and it is the spring, okay, the spring, and the third one is the PDE. Okay, I hope you will review. Okay, I think this is the end of this tutorial. Okay, I hope that you can review these 3 topics, okay, by yourself. Okay, thank you very much.